Okay, on this problem, we're setting up a system of linear inequalities. So here we have, for each problem below, we're going to write an expression in the form ax plus by plus cz in the first blank, then choose the correct sign in the second blank, then type in the constant for the second fill in the blank right here. So on this problem, x is the amount of bluegrass, y is the amount of rye seed, and z is the amount of Bermuda seed. So on one it says top grade turf lawn seed mixture contains 3 types of seed: bluegrass, rye, and Bermuda. It says in each batch there must be at least 30% bluegrass seed. Okay, so the amount of bluegrass seed is x, and that amount right there, x, must be at least, and at least means that much or more, or in other words, greater than or equal to of 30% of the entire amount. We'll see that here again. So top grade turf lawn seed mixture contains 3 types of seed, and in each batch there must be at least 30% bluegrass seed. So the amount of bluegrass seed must be at least 30% of that bag. And what's in the bag? Well, this stuff, the x, y, and z. See, the x stands for the amount of bluegrass, and the y is the rye, and the z is the amount of Bermuda. So when you add that up, you get the entire bag, and 30% of that entire bag is what has to be just the x part, the bluegrass. And in fact, the bluegrass has to be at least that much. So this is the inequality that you have to get from those words. Now, this has to be in this form right here. The first one has to be in the form of ax plus by plus cz, then your inequality sign, then a constant over here. Okay, so what we have to do is simplify this by taking the 0.3 times each one of these. Then what I do is I have to move all these terms to the left. Well, when I do this, right here is really 1x. And then this 0.3x gets subtracted off. Well, if you take 1 minus 0.3, you can use a calculator if you like, you get 0.7. 1 minus 0.3 is 0.7. And each of these gets subtracted and move over. So that's negative 0.30y, and this gets moved over, negative 0.30z, and there's nothing left on the right hand side because we moved everything over to the left. And what do you have here? Just a 0. So you type this in on the left hand side exactly like this. You choose the greater than sign, and then the third area right here, you just type in 0. Let's go ahead and do the second blank. But really the hardest part is what we went over first in terms of getting this equation. Once you get this equation, then it's just a matter of distributing and moving some terms to the left. So let's work on getting the second equation. The second inequality says the amount of Bermuda seed is at most 30% of the total amount of bluegrass and rye seed. Pretty similar to the last problem, just different variables used here. So this one says the amount of Bermuda seed, and when you look here, the Bermuda seed is z. So that's why this one starts off with z. Now this one doesn't say at least, this one says at most. And if you say at most 30%, that means it's that much or less. Like if you are at most 20 years old, that means you're 20 years old or lower or younger. So at most 30% means 30% or less. So we need a less than or equal to 30% times the total amount of bluegrass and rye. Well, bluegrass was x and rye was y. So that's why it's 30.30, 30% times the total amount of x and y. Now we have to simplify this. So we have z is less than or equal to, take your 0.3 across and you get 0.3x plus 0.3y. Move both of these over to the left-hand side, making both of them negative. So you get negative 0.30x minus 0.30y plus the z that's already there is less than or equal to 0 because we moved everything to the left-hand side. Over here it says question 1 and 2 of this type of problem were examples of, in the example, these are constraints. These are not what you're trying to maximize. This is what you're restricted to, these conditions here. Well, question 4, it says the cost per pound of the bluegrass, rye, and Bermuda seed is 35 cents, 40 cents, and 85 cents respectively. You want to minimize the cost, so use C for cost. So we need to type in over here this is going to be an objective equation for you're either minimizing it or maximizing. So it's 35 cents for the bluegrass. Bluegrass was X. 35 cents is 0.35. So it's 0.35 cents for every pound of this bluegrass stuff, X. Then it's 40 cents for every pound of this rye, so 0.40 times Y. Say Y was the amount of rye. And then 85 cents for every pound of this Bermuda, and the Bermuda was Z. And that's where the 0.85Z comes from. And that equals my cost. So this sign right here would be an equal sign, and that would just be a C. And again, this is an objective equation for problem 5 here. This is an objective equation is the choice on that. And that's how you do this problem. It's a good problem. We don't have to solve it. We just set it up, and that's all there is to that.